Okay, Year 8, we're up to our third video for this topic of Pythagoras' theorem. In this video, we're going to learn how to find the lengths of the short side in a right-angled triangle. So this is what we've learned so far. We've talked about what Pythagoras' theorem actually is, and we've learned how to write it. And then we've found the length of the hypotenuse. We also talked about approximating solutions and also about showing sufficient working out. So we can also use Pythagoras' theorem to find the length of a short side. And if you have a look at this triangle here, it's a little bit different to the ones that we've been doing. The pronumeral is not on the hypotenuse. Instead, it's on one of the short sides. But we're going to start the same way by writing Pythagoras' theorem, which is going to be 15 squared is equal to m squared plus 12 squared. Now let's work out this 15 squared and the 12 squared. And now we're going to have to use our skills at solving an equation. So we want to get this m squared by itself, which means we need to move this positive or plus 144. It's going to come over the other side as a minus 144. And then we're going to rewrite it. So m squared is equal to 225, take away 144, which is equal to 81. Now we're back to the last step of Pythagoras' theorem, which is let's get rid of the square by doing the square root of both sides. So m is the square root of 81, which is 9. And so have a look through there, make sure that that makes sense to you. We've still started with Pythagoras' theorem. We've had to solve an equation, so there's sort of one extra step, and then the ending is the same. Let's do another one. Find the value of x to one decimal place. So start by writing Pythagoras' theorem. 4 squared is equal to x squared plus 3 squared. Now let's work these out. 16 is equal to x squared plus 9, and then we're going to take this 9 over the other side as a minus. So x squared is going to equal 16 take away 9, which is 7. And then the last step is to do the square root. So x will be the square root of 7, and we can see that that's not going to be a nice number, so we're just going to approximate it by putting it in the calculator. And so our answer is 2.6. Now it's really important that you can tell the difference. Have a look at these two questions. Same numbers, same pronumeral, but one's got the x on the hypotenuse, and in the other question the x is on a short side. Can you tell which is which? So this one here is a short side one, so we're going to write 5 squared equals x squared plus 3 squared. Whereas this one's got the x on the hypotenuse, so it'll be x squared equals 3 squared plus 5 squared. Let's work them out. So we've got 25 is equal to x squared plus 9. Now we're going to take this plus 9 over the other side, becomes minus 9. X squared is equal to 16. Square root both sides, x is equal to 4. Now let's do this one. Here we're going to have 9 plus 25, which is equal to 34. Square root both sides, x is equal to 5.8. Now, one of the most important habits that mathematicians have is they check their answer. Have a look at this question here. We ended up with x is equal to 7.2. Let's substitute that in and see if it makes any sense. Does it? Something wrong, isn't there? This side has ended up longer than the hypotenuse, and that can't be because the hypotenuse is the longest side in a right-angled triangle. If we have a quick check back, you can see there's something wrong with this very first line here. This should have been 6 squared equals x squared plus 4 squared. So let's do it properly. So we want to start with 6 squared is equal to x squared plus 4 squared. Working these out, we get 36 is equal to x squared plus 16. Subtract 16 from both sides. X squared is equal to 20. And then do the square root. X is equal to the square root of 20, which is 4.5. Okay, let's substitute that in and see whether that makes sense. It does, doesn't it? Because both of these are smaller than the hypotenuse. And of course we can have practical problems. A flagpole is supported by 2 wires, each of length 3.2 meters. If the wires are attached 1.4 meters from the base of the pole, how tall is the flagpole? Now there's a bit of extra information here that we don't need. We don't need this side. All we need is this right-angled triangle here. We know the length of the wire is 3.2 meters and it's attached 1.4 meters from the base of the pole. And we're going to call this H. Okay, so 3.2 squared is equal to h squared plus 1.4 squared. Let's work these two out. 10.24 is equal to h squared plus 1.96. Subtract 1.96 from both sides. So h squared is equal to 8.28. Then finally do the square root. H is equal to the square root of 8.28, which is 2.88 meters. Let's do one more. Amelia's kite is caught in a tree. The kite's string is 15 meters long. She stands 10 meters from the base of the tree, and the string is 1 meter from the ground. How tall is the tree? Okay, so the first thing we know is that the kite's string is 15 meters long. Now we need to construct a right-angled triangle. We know that she stands 10 meters from the base of the tree. That's going to form a right angle for us. We're going to call this section of the triangle H. All right, let's do Pythagoras' theorem. 15 squared equals h squared plus 10 squared. Working these out, 225 is equal to h squared plus 100. Subtract 100 from both sides. So h squared is equal to 125. And when we do the square root, h is going to be equal to 11.2 meters. Now that's from there up to the top of the tree. We're going to have to add this distance in, which is 1 meter. And so the tree is 12.2 meters tall. Okay, that's it for this video. In our next video, we're going to look at irrational numbers.